Question 2. Today you take out a $5,000 loan at 10% compounded quarterly, which is to be repaid with 2 equal payments at the end of the first year and at the end of the second year. A, find the size of the payments, and B, how much interest will be paid. If this question looks familiar, it should. It's the exact same question that we did in question 1, except that now we have, I'm just going to circle 2 equal payments. Now, instead of having simple interest, we have compound interest. As before, I'm going to start by drawing in my timeline. Today, 1 year, 2 years. But everything here is quarterly. So I'm going to say J4 equals 10%, which means that I is 10% divided by 4, or 2.5%. In case you're wondering how I did that, 10% is 0.1, and I divided that by 4. So let's use today as our focal date, just because that's what we did last time. Here, though, we get a lot more leeway. In compound interest, no matter where you choose your focal date, you're going to come up with the exact same answer. That means that we could choose something where the equation looks nice in algebra. But what we're going to do today is just do the same thing we did before, except now we're using the compound interest formula. I'm going to state what X is. So X is the size of each payment. And I'm going to put a note. Any focal date will do in compound interest. This isn't true in simple. Simple interest is not as elegant, and it does matter where we choose the focal date. So the two people that are arranged in the lending, have to choose one together. So let's put our money borrowed equals money paid, or money in, money out. Our money borrowed was $5,000. And our money paid was that first payment of X, but it's going back in time 1 year or 4 quarters. If you're not sure about these payments, these measurements, go ahead and put those quarters in. So this is 1 quarter, 2 quarters, 3 quarters, etc. That helps. Now let's add that second payment, also 1.025, but this time it's going 8 quarters into the past. Let's calculate this. There are lots and lots of ways to calculate this, but I'm going to do just one way. What I'm going to do is I'm going to move everything over to the other side. I'm going to note that X over 1.025 to the 4 is kind of like this fraction times X. And now I'm going to use the calculator. Scroll up a little. 1 divided by 1.025 to the power of 4. That's a big long number, so I'm going to store it. I press store and then 1. And that is 0.9059 ... X. Anytime I store something, I like to write down what I stored it as so I can get it back. Let's do the next part. 1.025 to the power of 8, and then it was 1 over that, so 0.82. And I'm going to store that as 2. And again, let's write down that that was stored as 2, and that whole thing equals $5,000. Now I can factor out that X. So this thing here, well, that's going to be recall 1 plus recall 2, and it's 1.72666. Another big number. Every time I get to these big messy numbers, I like to store them. Store 3. So now I have, let's scroll up a little, 1.72669x, and that's the same as store 3. And that equals $5,000. And now we're back to a similar place where we were. I can divide both sides by that. So now I have x equals this guy. So I have 1.72669. I'm going to clear $5,000 divided by recall 3 is this. 2895.70. It's different than we had before. And I'm going to end this with a sentence. Each payment is $2,895.70. Interest is the same way. So we paid, well, money paid minus money borrowed in interest. Same thing here, only we have a different payment. We borrowed $5,000. So I'm going to clear this just so that I don't have to worry about those trailing decimal places, though if you use the decimal places, it's not the end of the world. Okay, we paid $791.40 in interest. That's not dramatically different than before, but if I'm going to scroll up to question 1, we paid $739, so that's a lot more. In general, that's going to be true. The longer a time period we invest for, the less we're going to pay in interest charges with simple and the more interest in compound. If we're investing the money, compound is going to be better in the long term because we end up with more money.